So here's your periodic table, right? You guys have a sketch of this? So if we talk about shielding, where does shielding increase? The groups, but in particular, what direction does it increase? Going down a group. So, going down a group, I increase in shielding. So all these arrows, I'm going to point in the direction of increasing. All right, what about ENC, effective nuclear charge? We're talking about periods. So going across a period, we have ENC increasing. All right. What about atomic radius? What happens as we go down a group with atomic radius? It gets larger. Why? Why? Why does it increase? It increases because, what am I pointing to? Shielding is increasing. The more layers you have, the bigger your atom gets. So as I add more and more layers, my radius gets larger and larger and larger. What about as I go across? What happens as I go across a period to the atomic radius? It gets smaller. So atomic radius gets smaller as you go from left to right on the periodic table. So the opposite is increasing. If you go right to left, we're losing protons, and therefore the radius is getting bigger and bigger and bigger. So again, why does the atomic radius decrease going across the periodic table? Yeah, the ENC increases. And as the ENC increases, remember, we have the same amount of shielding, so as we add more protons, my valence shell gets pulled closer and closer and closer to the nucleus. Thus, we have a smaller radius. Now, first ionization energy. Yeah. So, if I drew the arrow going from left to right, the atomic radius would be decreasing. So, because I drew the arrow the opposite direction, it's increasing going from right to left. From left to right, it decreases. From right to left, it decreases. Sorry, increases. Geez. Sorry, my bad. So, let me just draw it. So, if I go the way I read, from left to right, atomic radius decreases. Does that make more sense? All right, so I have both directions drawn at this point. Okay. What about first ionization energy? Going down a group, what happens to the first ionization energy? Remember, this is the energy it takes to pull an electron off of an atom. So we're looking at how well that nucleus has a hold of that electron. It should decrease. So first ionization energy should decrease because why? Yeah, it doesn't have as good of a hold on it because of the shielding increasing. So the more layers of electrons I have, the less grasp that nucleus has on that valence electron. What happens as I go across a period? Do the atoms have a better hold on that electron or less of a hold? As I go across a period, what happens to first ionization energy? Does it increase or decrease? Remember, I'm adding protons. I'm increasing the E in C. So that means as I add more positive, will it have a better hold on the negative? Yeah. So if I look at boron, boron has 5 protons. Carbon has 6 protons, then 7, then 8, then 9, then 10. As I add one more proton each time, each atom increases its ability to hold on to an electron because it's getting more positive. So if it holds on to an electron better, will it take more or less energy to pull that electron off? Should take more. So first ionization energy increases going across a period. Yes?
Is there like a chemical reaction?
All right, the last one I'm going to ask you about is electronegativity. Now, electronegativity is the attraction or the pulling power a nucleus has on electrons that are in a bond. So, here, oops, drew my shell the wrong way. Here, how much pulling power, which atom here can tug on these electrons the most? Okay? That atom has the higher electronegativity. So, if I pull my electrons towards this atom more than this one, that means that this has the higher electronegativity. So, as I go down a down a group, what happens to electronegativity? Again, we're looking at the attraction between the nucleus and valence shell. It should decrease. Okay? Because I add more shielding, my electronegativity decreases. What happens as we go across a period? It should increase. Why? It increases because why? Increase in E and C. Increase in the attraction between the protons and the electrons. So this is kind of a summary of everything that we've talked about in sort of a graphic organizer.